All right, so today I'm going to be going through the commissioning and startup of the Vitoguide 200 or the CI2s. From here on out, if I refer to this, you're probably going to hear me refer to the CI2. So again, that's the Vitoguide 200. This is going to be eventually replacing the CM2, although I have been told they will not be discontinuing the CM2 until there is strong and adequate production of the CI2. So the CM2 is still available for order for now, and eventually it will be phased out and it will be all the CI2 that you have able to order. We're going to review some of the required apps and Viessmann accounts that you need to commission these boilers. We're going to discuss commissioning using the ViGuide app. We're going to detail some of the necessary checks to do during commissioning and startup of the boiler. We're going to review some of the common coding options, and we're going to discuss how the alarms are handled. So there's a new alarm handling format in the E3 controls. If you're familiar with the Vitoguide, it's pretty much the same as that. But if you're not familiar and you're familiar with the older generation of products, it's quite a bit different. So we're going to take a nice dive into that and how that works. Starting out with some startup and checkout procedures. So first things first, we want to fill the heating system. So you're going to fill the boiler with water in accordance to the water quality requirements in the manual. We often get questions about this. Keep in mind that this is total parts per million of calcium carbonate. This isn't total dissolved solids. Every once in a while we get questions. People think that this is total dissolved solids. No, that is not the case. If that was the case, you'd be looking at pretty much distilled water. And that's in many cases, you do not want to use distilled water. If there's metal piping, you're going to suck all the minerals out of the piping. So this is just calcium carbonate, okay? We recommend that you record the fill volume and the water hardness and pH values on the table on page 82 of the manual. I mean, if you're using your own system to record values or the building operator has a system to record values, that's great too, but it's strongly recommended that you are recording it and keeping a log. You can obviously set the pressure. So these are a minimum pressure of 15 PSI and a maximum pressure of 80 PSI, and they do come shipped with the 80 PSI PRV valve. If you have any doubt about the water quality, it is strongly recommended that you get a proper water analysis done. Water quality is going to be instrumental to the life of both the boiler as well as the rest of the system. So don't skimp out on the water quality. As just an example of what that table looks like in page 82. If you're using your own similar table, that's great. Be mindful that tech support may ask for this, or if there's any warranty inquiries, you may be asked to produce this information as well. So do log it somewhere. If you fill the heating system and it is filled with water that isn't fully softened, however, it's water that does meet the requirements, we recommend that you do the following to prevent calcium buildup on the heat exchangers. So we're suggesting that you start the system with the pump at 100%. So you're going to go into actuator test, you're going to drive the pump up to 100%, and then you're going to start the boiler in low for a bit and run it that way, and then ramp it up to high. So slowly heat it up and then ramp it up to high. This is going to prevent localized concentrations of lime scale deposits on the heat exchanger. If you're doing multiple boilers, so if it's a cascade system, we recommend that you're going to do that and you're going to start all boilers at the same time, just so that one boiler isn't going to see all of that lime scale in that heat exchanger. You obviously want to confirm your venting and combustion air, but for combustion air, we want to make sure that in a room air dependent situation that you're making sure that your combustion air openings in the mechanical room are open and that they're adequate. And you want to test any combustion air proving interlocks if that is applicable, and check for the proper filter installation if used. So these, as you can see here, you can add accessory filters right to the burner fan inlet. So we want to make sure that they're using the appropriate filter and is properly installed and in good condition. For room air independent operations, you want to make sure that the pipes are not obstructed. You want to make sure that your terminations are in line with local code and the manufacturer's instructions. Scott did a presentation on installation a week back, and he has some really good slides on how you're going to set up your terminations and the requirements there, so you can check those out. And we also recommend checking for proper filter installation again. So the way that these boilers are is there's essentially two burner sizes. There's a 1 million BTU burner size and a 500,000 BTU burner size. If you have a 750,000 BTU boiler, that is a D-rated 1 million. And if you have a 399,000 BTU boiler, that is a D-rated 500,000. So with the two sizes of burners comes two sizes of filters, the larger size and the smaller size. So just make sure, if it's a dual, you should have two larger filters. If it's a 2 million dual, you should have two larger filters. If it's a 1.5, you're gonna have a 1 million and a 500,000 BTU burner. You should have a mix match set of filters. Make sure that the proper filters are used. Condensate trap is likely to be installed by the installer, but you want to make sure it's in there before you start the boiler up. It is shipped with the boiler, but not installed. The key part here is we recommend that you're using neutralizers, as many local codes will recommend that or require that as well. But the key part here for the startup technician is that the condensate trap is equipped with a float. So if there's no water in the trap, the float is closed, the flue gas cannot enter through the condensate pipe. So really you don't have to pre-prime the trap because of the float. You also want to make sure that your end of line termination switches are in the correct position. So if this was a single boiler, there's no cascading going on, it's not communicating to a WAGO control, then that switch should be in the off position. Once you start communicating across the external CAN bus, be that to other boilers in the cascade or a WAGO control, whichever devices are at the end of your daisy chain need to have the end of line switch turned on. So in this particular example, we're looking at boiler 1, 2, and 3, 1 being the lead boiler, 2 and 3 being the legs. Because 1 is at the end of the line, it's the first one on the line, and 3 is at the end of the line, it's the last one on the line. Those switches will be on and 2 will be left off. If there was a WAGO gateway control in front of boiler number 1 in the daisy chain, its end of line termination would be enabled and boiler 1 would be off, boiler 2 would be off, and boiler 3 would be on, because again, it's the end of the line. Switch is located on the this board here. It's next to the 91 plug. It's a bit tight to get in there. I recommend using like a pocket screwdriver or something. And there's no labeling for off, but on is up and off is down. It does say on and it says 1 for the down position. These do or should come defaulted in the off position. Commissioning. So the first thing you need to commission the boiler is an account. If you're going to do it through the app, which we strongly recommend doing it through the app. And if you're going to do a cascade, you must do it through the app. So there's 2 levels of account that you can have. You can have a full account or a light account. Now, we are encouraging everybody to get a full account. I will go through the instructions on how to get a full account. However, in order to get a full account, because you're going to send some information to us and then our administrators are going to administrate it and then set that up for you, it may take a day or 2 to get it set up. So in the event that you end up on site, you're in front of a boiler, you're doing a cascade, you just found out that you need to download the app and you need an account, you can set up a light account on the fly. And how you're going to do that is, again, you're going to download the app. You're going to see this login button. You're going to be like, I don't have any login information. And you're going to go register. Once you go to register, you're going to get some information that starts your registration. So you're going to put in your first and last name. You're going to select, I do not have a customer number. I'm going to put a pin in that for a second. You could select that you have a customer number, but there's many caveats to go with that. So we're going to say I do not have a customer number. You don't know your customer number. So again, you're going to put in your first name, your last name, your company name, your heating contractor, postal code, your city, your email address. And this has to be an email address that you have access to because you're going to be asked to confirm registration. In the event that the email address you inputted is already used, you will be asked to provide a unique username. It's okay that there's more than one account registered under the same email address. It's just the first account registered under that email address. The email address becomes the username. Any subsequent accounts registered under that email address will require you to enter a unique username. That's your login username. You're going to put in your phone number and create a password, preferably something that you can remember. Indicate your country. You're going to agree to the privacy statements. You're going to read the information and agree. You're going to indicate that you're not a robot. You will probably be prompted to select how many of the following tiles contain a chimney. It will be vague and you will be frustrated. Once you get past that, it will indicate thank you. Whatever you put in for your username. I've got Johnny example. We have sent you an email with a confirmation link to your email. You're going to then go into your email, open the email from Viessmann, click complete registration. It will now say your email address has been confirmed and your account is now active. Once you get that message, you can then go back into the app and log in using either the email address, if that's what was used, or the unique username and the password you entered. So that is how you would do it in a pinch if you needed to set up a light account. I've done it many a times. It can be done in a minute or two. You do need to have access to the internet though, because you're going to need to pick up your email. That's the key. As far as a full account is concerned, this is the preferred method. So anybody who's in this presentation today, obviously have some interest in the Viessmann CI2, I would recommend you set yourself up for a full account if you do not already have one. To do this, you simply go to our website. You're going to click the services tab on the top. You're going to get this drop down come up and you're going to select Pro Toolbox. Once you've selected that, it's going to populate to this page. If you're zoomed in fully, you're probably going to see it cut off around here. I zoomed out just for the screenshot, but you would scroll down and then select Viessmann account. And then it will populate this Google form in which you're going to put in some information. You're going to put in your first name, your email, your phone number, your job title. As you'll notice, this is very similar to the information that is asked of you in the app when you create a light account. Your company address, company email for general requirements. Anything with an asterisk is required. Anything without an asterisk is an optional field. And your company phone number. Now we may come back to you. An asterisk as being required means you need to put that in for the form to even be accepted. We may come back to you and say, no, we need a company phone number in order to complete this registration. And then you're going to hit submit. Once you hit submit, that information will go to one of our administrators at Viessmann. And what they will do is they will take that information, they'll look in our database and say, hey, this person does or does not have an account. If they don't have an account, when I say an account, I mean a business partner account. So this is different than the light account or the full account. Every company or contractor has a business partner's account, and then underneath that company is individual user account. So what you're registering here for is an individual user account. But if you send this in and they say, hey, there's not even a business partner account associated with this particular contractor, then our administrators will go through the legwork to get that set up. They may email you back and ask for any information needed. And they will then set you up for both the business partner account and the Viessmann account to use the app. And all they'll do is send you a link. You'll open the link. The account will already be set up. You just have to enter your password. Okay. If we go to this next one here, I mentioned If you knew that you had a business partner account and you knew your account number, you could select uncheck this box and attempt to register a full account right through the app. The problem is with that is all of this information has to go in exactly as we have it in our system. So the company name has to be spelled exactly. The postal code has to be the exact same in the exact format. The phone number must be identical. This is why, regardless, we recommend that you fill out this form. And like I said, if you fill out the form and one of our administrators says, hey, they do have an account, we're going to set it up for them, they'll just go through and say, okay, well, he put his name in as Johnny example, but in our system, it's Johnny R example. So I'll just put in Johnny R example, and then it will go through without an issue. So either way, there's two ways you can set up an account. We recommend the full account. We recommend you do it ahead of time so you're ready to go, but in a pinch, you can set up a light account. Once you've got your account set up, you're in front of the boiler. Well, what's the first thing you're going to do? You're going to turn the power on. So on very first power up, so imagine you just installed this boiler. It's the first time it's been powered up outside of the factory. You're going to get it boot up into the language selection screen and the commissioning screen. On any subsequent power startup, so you shut the machine down to perform a maintenance and you turn it back on again. So long as it's already been commissioned, it will then boot into the default dashboard screen you have selected. And I will show you how to select the default dashboard screen. If at any point in time you want to recommission the boiler, the commissioning menu can be called up quite easily. You just do that via the service menu. So you would go in to the menu, select service, enter your password, select commissioning, and do you really want to carry out commissioning? Yes, of course you do. So how would you, actually I should go back a couple slides, my apologies. So the control does incorporate a commissioning assistant. So whether you use the software tool, which is the app, or the programming unit, you will be brought through a commissioning assistant. This is quite handy because it basically prevents you from missing any important steps. It's going to guide you through the process, and it's going to be question and answer based. So the startup or the commissioning assistant is broken into three categories. It's broken into basic, advanced, and additional settings, and I'll go through each of those. So we're going to go through how you would pair to the system using the ViGuide app. So once you get to this screen, whether you did it because this is the first time you've booted up the boiler and it automatically booted into the screen, or whether you re-entered the commissioning mode as we just discussed, you're going to end up here. You're going to select software tool. There is a screen in between here. This is a little misleading. Once you select software tool, the thing will boot down and say entering pairing mode. This can take up to 60 seconds. Once it's done that, it will then go into this commissioning with software tool and tell you to follow the steps in the software tool. So the thing it will tell you is you're going to go in, you're going to open the app, and you're going to select new system. If you're doing just one boiler, you're going to select a single commissioning. If you're doing a cascade, you're going to select cascade commissioning. Then you're going to pick your boiler from the list of options. In this particular example, we're going to look at a Vitoguide. Then it's going to ask you, has the appliance already been commissioned? Really, the significance of this question is you can say yes, reconfigure, or no, start commissioning. Really, all this does is if you say yes, it'll populate this screen here, which tells you how to re-enter commissioning mode, which I just went through. If you say no, it knows you don't need to re-enter commissioning mode, and it just goes right to this screen here. So you're going to hit continue with QR code. If for whatever reason, so there's a QR code on the boiler and you can scan that. So this QR code, when the boilers are shipped, it's in a little pouch on the front of the display. There's 3 or 4 stickers in there. We recommend taking one sticker, placing it somewhere on the boiler that people can access. So don't put it on the side, if it's going to be in a cascade and the boilers are going to be right tight together, obviously that's not going to work. So one sticker on the boiler somewhere that can be accessed. One sticker in the operator or the user's manual. There's actually a spot right in the manual to place the sticker, and I recommend putting one sticker in the service manual. There's a spot to place the sticker in the service manual. This way, there's a very good chance you will be able to get at the sticker at any given point in time. Also, the end user will need access to this sticker as well to set up their own access. So make sure it's somewhere that they have access to it as well. In the event your phone cannot scan the QR code properly, you can manually connect. So if there's something wrong with your phone and it's not able to scan the QR code and connect, just go into your phone or tablet Wi-Fi settings, search networks. If this was the example, you would see a network called Viessmann-22214. You're going to hit connect. It's going to ask for the password, and you're going to enter this WPA2 number in the password. Once you either scan the QR code or manually enter it, you're going to get this indication here on your phone or tablet. It's going to say ViGuide, that's the app you're working in, wants to join Wi-Fi network, and you're going to connect join, and it will then indicate connected. Now, just be mindful that the serial number displayed here is the serial number of the boiler itself, not the serial number on the Wi-Fi sticker. The serial number indicated on the Wi-Fi sticker is specific to the Wi-Fi module, okay? The number that appears on this screen is specific to the boiler itself. So just don't get caught up on that. Once you click continue, it'll jump right into the commissioning assistant. It'll start in basic. So under the basic menu, you're going to pick your units of measurement, be that metric or imperial. You're going to select your date format, your time format, and whether you want to use auto daylight savings time. If you're using your phone to do this, which for the majority of this presentation, I'm going to be assuming you're using the phone, your date and time will auto-populate. That information will be pulled off your phone and brought into the app and auto-populated. You're just going to select your format from there. You will then be asked whether it is going to be a weather compensated boiler or continuous operation. So are you going to be using outdoor reset, or is it going to be fixed set point? Going to ask you whether the flue system, so this is your venting system, is it a single flue system, as in your boiler is the only boiler on that exhaust termination, or is it multiple connections where you have multiple boilers terminating into a common flue system? Then it's going to ask you about your flue system length, and this is selected by the meter if you select metric, or the foot if you select imperial. And your fuel type, so whether that is natural gas or liquid propane. And I'm sure you've all had it beaten into you by now, but if not, I will say it again. The magic of these boilers, and pretty much most of the new Viessmann stuff, is that the conversion from natural gas to liquid propane is nothing more than a menu selection. There is no orifice to change. There's no mechanical springs to change. There's not even a set screw on the gas valve to change. You just simply select the fuel type via the menu. The only mechanical aspect you have to do is go into the instruction manual package, grab out the conversion stickers, and place them on the boiler where appropriate. At nearing the end of the basic portion of the commissioning assistant, you will have the opportunity to enter contractor details as well as put in some notes for the report. And we'll talk more about the reports down the line, but you can enter your contractor details. And what happens here is once you enter those contractor details, then in the event that there is a alert or an alarm on the boiler and the operator selects the information button, part of the information provided will be your contractor information. So it just gives you a place to basically put your business card right in the display. Another nice thing about this is, so long as you're using the same account every time you set up your boilers, you only have to put this information in once. This will hold within the app as you go from installation to installation. It will then indicate that you are done the basic part of the commissioning and ask if you would like to advance on to the advanced part of the commissioning. The reason that it then populates this safety alert is because once you go on to the advanced part of the commissioning, the boiler will now start to engage pump outputs and whatnot. So they want to make sure that the system isn't dry. You're not going to run your pumps dry. They also want to make sure that there's not an electrician down the line still wiring up a pump or something, and this boiler is going to surprise him by engaging the output. So once you get into the advanced portion, or what is also referred to as the system scheme, it's going to start out by asking you about your heating zones. So this thing can support up to 3 heating zone inputs. So these could be weather compensated if you have an outdoor temperature sensor, or they could be constant set point with or without an outdoor temperature sensor. There's no time program, so there's no internal time program in the controller, because these are intended to be used with a thermostat, and your thermostat would contain any time programs if desired. The 3 heating zone inputs, if they are not used for heating zones for thermostat operation, can alternatively be used for safety devices. So you can then program them for safety device 1, 2, and 3. Now, if you used, say, 2 zones for thermostat operation, you can still use 3 as a safety device. So whichever ones are left over can be programmed as a safety device if desired. Zone circuits cannot be used with a Vitotrol 200E because they are not part of the plus bus, and they are intended to be used with a thermostat, and they will be without a Viessmann mixing valve. I mean, you could use a thermostatic mixing valve or a third-party mixing valve, but again, they will not be brought into the plus bus and will not be able to be used with a Viessmann mixing valve. Once you've selected the information for your heating zones, you will get heating circuits. So you've got up to 4 heating circuits. Heating circuit 1 is always a direct heating circuit, and then 2, 3, and 4, if used, will be mixed heating circuits. So again, these are weather compensated or outdoor reset, so long as you have an outdoor temperature sensor, or they can be constant set point. Excuse me. They are not intended for a room thermostat. Again, they are built into the plus bus though, and can be used with a Vitotrol. So there's no requirement for Vitotrol. All the programming and setup and all that and adjustments can be made right on the boiler display. However, if you want to be able to make the adjustments remotely from within a room, you can use the Vitotrol 200, or if you want space temperature feedback, you can also employ a Vitotrol 200. And again, these are with or without mixing valves depending on the circuit. Circuit 1 is always direct without a mixing valve. 2, 3, and 4 are with mixing valves. Once you've picked your heating circuits and heating zones, you're going to set up your domestic hot water. So you've got the options of not installed. You could have a tank with 1 sensor, a tank with 1 sensor and a recirc pump, and then you could have a tank with a temp switch, or a tank with a temp switch and a recirc pump, or of course not applicable. Once you've selected that, we're going to go on to your low loss header settings. So if you selected no DHW, your options for low loss header are not installed, low loss header heating only, or buffer cylinder heating only. If you did indicate in the previous step that you do have domestic hot water, then you have the options of not installed, DHW upstream of the low loss header, DHW downstream of the low loss header, as well as upstream or downstream of a buffer cylinder. 96 plug. So the 96 plug is just a programmable dry contract on the boiler. It's got the option of no function. It could be external demand, external blocking, or a call for heat. Then you are going to be asked about your primary pump control. This is what it would look like on the display if you were doing a single boiler, or what it would look like if you were doing it through the app. So do you have a pump? You could have yes or no. Then if you selected yes, it will ask you, is it on-off control or variable? And if you selected that it's variable, then it will ask you whether, what is this variable 0 to 10 control? Is it going to be a fixed speed? You're just going to set an output and it's going to stay there. Is it going to modulate with burner operation? Or is it going to try to maintain a delta T? Those are your options there. There's also further coding addresses for this. So especially if you're doing delta T, you're going to go into some further coding addresses and set up what that delta T is going to be. After that, it will ask you about your Vitotrolls. If you do not, these are auto discovered. So if you do not connect any Vitotrolls to the plus bus, it's just going to basically say no remote control. You're going to move past that. If you do have some connected, it's at this point in time in which you can set what circuit you want that Vitotroll to be associated to. So that is the end of the advanced settings. It will now ask you if you want to make additional settings. Additional settings is basically going to be things that you can access through the HMI or the display after the fact. For the vast majority of them, it's actually home or end user preference settings that are available without even going into the service menu. So this basically gives you a chance just to use the app to set up things like scheduling and maintenance scheduling and whatnot. It's just a little bit easier than doing it on the display. So if you did select a yes, first it will start out with your heating circuits and heating zones. So you get a chance to name the heating circuit. Obviously, as I mentioned, you can imagine that's a lot easier to type in a name on a phone than it is on the touch display. You can set up your reduced temperature target, your normal temperature, and your comfort temperature. You can set up your time program. This is also, in my opinion, easier to do on the phone than it is on the display. You can set up your heating curve for that circuit and your minimum and maximum flow temperatures. So this is why I say it's mostly things for the end user. So all of these top items here, the end user would set up. They don't even have to go into the service menu or know the password. Minimum flow and maximum flow are coding options. So they can be done after the fact, but they are coding options. Just a little bit of an example of a discussion of how the heating zone heating curve functions slightly different than the heating circuit heating curve. Really, they function the exact same, except that the heating circuit has a third point of adjustment available to the operator of the boiler. So a heating zone is fairly self-explanatory. You've got your shift, which can be -13 up to +40. That's going to take this point, grab it, and pull it up, and the whole graph is going to come up with it as where your slope would bend these down. However, the end user has this third option here, which is a room temperature set point. That's basically done right on the control. You've got your normal room temperature set point, and it's defaulted at 20. That's sort of the baseline. And if you increase it or decrease it, it grabs this anchor point and moves it up or down accordingly. So they have a bit of a adjustment after the fact. If they're a little too warm, they can turn it down a bit. If they're a little too cool, they can turn it up a bit. Just a quick example of how you might use these heating curves. So in this example, we're looking at a design day with a set point of 74 degrees. So I imagine this is going to be something like Toronto, where your design day is 20 degrees Celsius. And on that, they're looking for a set point of 74 degrees. Well, if we look at the default heating curve of 0 and 1.4, well, that just happens to work out perfectly. Great. However, If there needed to be an adjustment to the base load day, say we needed to come up 25 on the base load, as you increase your shift, so at default, the start is 20. So if you added 25, it would take you up to 45. If you increase your shift without adjusting your slope, well, now you'll see once we get to our design day of -20, we're looking for a boiler water set point of like 98 degrees Celsius. That's not going to work. So we are going to compensate for that by lowering the slope. Now we got our base load day where we want it, and we're just going to drive down that slope until it lines up where we want our design load day, which works out to 0.8. So that's how you make your adjustments with your heating curves per application. Still in the additional settings. So that was, you could set up your heating curves under additional settings. Now you're going to get to your DHW. So you can set up your DHW set point, your time program for DHW, your hygiene function. Is it on, is it off? When do you want it to start? And what day of the week do you want it to start? And lastly, we get some gas condensing boiler questions. So these are going to be your maintenance questions. So define maintenance interval on calendar. So how much physical time passes, months, or how many run hours of the burner, as well as it gives you the opportunity to set up maximum heating output. Once you select that, you will get commissioning completed on the app. And on the HMI, it does come up and says, do you want to terminate commissioning? This is poor translation, okay? This should really say, do you want to finish commissioning? Do you want to complete the commissioning? Do not panic when it says, do you want to terminate the commissioning? That doesn't mean that it's going to drop all of the entries you just put in. You just view that as, do you want to complete commissioning? You hit the check mark, the display will boot down and boiler will boot back up and you're good to go. If you're doing it through the app, you will get the additional question of device connectivity. So now this is asking, do you want to, basically when you're doing it through the app, you've got that boiler in the local hotspot mode, and that boiler is producing its own little Wi-Fi hotspot, you're connected to it. Now what it's asking you is, do you want to release this hotspot and allow the boiler to go out and look for a Wi-Fi network? So if you selected yes, it will then go and look for any of the available networks out there. You find the network that you want and you enter the password, hit save and done, and it will then connect to that network. Now the boiler is sitting out there on the old World Wide Web, and it can be discovered by our technicians through the ViGuide, through some of special software they have, and whatnot. So if once you've done that, it will ask you if you want to view the commissioning report. So you can select yes or no. It will also ask you at a point in time if you want to share the commissioning report. So if you said, yes, I want to view the report, you can also share it and send it to a specific email. These are just a couple of screenshots. The commissioning report is going to consist of all of the settings you put in, and then some other stuff you didn't put in, like firmware versions of certain hardware and the boiler serial number and whatnot. It's a very nice, detailed, complete list of everything that was done by you, plus some background information of the boiler itself. Once that is done, if this was a single boiler, you would hit continue. It would boot down and boot back up, just like when you hit terminate commissioning through the HMI. So again, it's going to follow the same processes. If you're doing it through the HMI, you do not have the opportunity to connect it to the Wi-Fi at that time. It just says complete it, boots down, boots back up. If you're using the app, it will ask you additionally if you want to connect it to the customer's Wi-Fi, as well as if you want to view and share the commissioning report. Now, if it's a cascade system, so you're not doing a single boiler, you selected cascade system, it's going to pop to this screen. So when it says commissioning complete, That means for that particular boiler in a cascade, not the entire process is completed, just that boiler's commissioning is completed. You're going to come here, and so you've seen you've done the first device. That's why we've got a little green circle check mark next to the first one. You're going to click commission additional devices. You're going to click the second device, device ID 2, and continue. Now you're doing the commissioning assistant, guided commissioning assistant, but for the lag boiler. So you'll see it's much more streamlined because there's way less information to put into the lag boiler. So it's this simple. Your basic configuration is it a single connection or multiple or common venting? What is the length of your vent? It does ask about heating zones. You cannot set up a lag boiler heating zones for thermostat inputs, but you can still set them up for safety devices. So if you wanted to have a low gas pressure cutoff or a high gas pressure cutoff specific to that boiler, you do have the option to set that up. And then you do also have the additional settings, except the only additional setting is maximum heating output. So you could, on a cascade, technically limit the heating output of one boiler different than another one. Once you select that, you're going to hit continue, and you're going to get back to this screen. Again, now we've got a green check mark next to our lead device and our lag device. If we had multiple lag devices, they would be listed here. We'd select commission additional device, and we just keep going through until we hit a green check mark next to each device. In this example, I only had 2 boilers in my cascade. I hit continue, and I'm asked about the appliance sequencing strategy. I have the option of dynamic or fixed. If I select fixed, I can simply choose which device is the fixed first and which is fixed last. So it says device 1, select ID. So if I actually wanted the lag boiler to start first, I would say device 1 is device ID 2, and device 2 is device ID 1. Or if I'm selecting dynamic sequence, I'm going to go for runtime optimization, and I just choose the amount of hours before it switches which one is fixed first. Then it's going to ask you, what is the type of DHW heating? So this is an important question. It's going to say, is it local, as in the tank is directly connected to the lead device, or is it global and that the tank is connected after the low loss header? So what exactly does that mean? Well, here's an example of a local DHW setup in a cascade. You can see we've got 3 boilers in our cascade, but our domestic hot water, our tank loading pump, is connected directly to the lead boiler. In a global example, our tank loading pump is connected and tied in on the common supply piping, the common system piping. So that's a global example versus a local example. The reason that you want to set this up is many, but if you set it up for global, you can, if you set up for global, then you have the option of whether you want your heating circuits to have priority over DHW. And if you set it up for local and you set it up correctly, the lead boiler can produce DHW while the remaining boilers are still producing heat for the system. So you can produce domestic hot water off the lead boilers while the lag boilers produce heat for the system simultaneously. So now that you understand what this means and you've picked one, you're going to hit continue and you're going to get system reports. Do you want to view and share the reports? If you do, go ahead, great. If not, you hit finish. And now, because that was it, now both boilers or all the boilers in the cascade, the screen will boot down and boot back up, and it has been successfully commissioned. General settings not in the commissioning assistant. So some things that are some key settings that don't reside in the commissioning assistant. You've got your buzzer sound on and off. You can turn the light guide on and off. Now, if you turn the light guide off, the light guide goes off only when the boiler screen is asleep. Okay, if you start touching buttons and you bring the display alive, or if there's an alarm, the light guide will come back on at that time. You can select brightness of your display, and that can be done from 10 to 100% increments. You've got your screen lock options. So you could lock the screen so that it allows the customer to see dashboards only, or you can lock it so that it's fully locked. You can change the default password, and you can select you get the selection of your default dashboard as well as some energy cockpit tweaking. So your energy cockpit tweaking is going to be like your gross calorific value and your gas volume correction factor. Those are information you're going to have to obtain from your utility provider. They just allow you some adjustment of the nominal values to get more accurate energy consumption tracking. Here's an example of your default dashboards. So you've got the option of heating, DHW, or device status. Now, if you didn't have DHW selected, obviously you wouldn't have that option there, or vice versa for heating. If this boiler was used for DHW only, that would not appear. But you got your heating, your DHW, and your device status dashboard, and that you choose which one you want to be the default. When you're looking at the heating one, you'll notice here it says heating circuit 1, and there's a drop down arrow. If you had 4 heating circuits in 3 heating zones, you hit that drop down arrow, you're going to see all 4 circuits and your 3 heating zones listed. You can pick whichever one you want, and to the best of my understanding, it will just always go back to the last one you selected if you selected heating as your dashboard. So basically what you're looking at here is some general settings, heating and DHW. This is more or less part of your additional settings that if you chose to not select additional settings in the commissioning assistant, or you're doing it from the HMI, you will do it here. So you will select heating, then you will select your circuit type or your zones. And your zones, you will be able to pick from however many zones you have. You can set up your heating curve and make adjustments there. If this was set up to be a non-weather compensated, instead of heating curve, it would just give you a set point. Heating circuits, pretty much the same thing, except in addition to heating curve, you've got time program and set room temperatures. And heating curve, again, if those heating circuits were set for fixed set point, would be replaced just with a flow temperature set point. DHW, same idea. You can adjust your time programs, set your hygiene function, scald protection on off, and DHW set temperature. Taking a look at some of the accessory modules, just excuse me for 1 second, drink. Of course, when I go to present is when my throat gives me issues.
You sound like me.
What's that?
You sound like me. That usually happens to me.
Yeah, exactly. Destiny.
Ontario's very dry. Must be.
It's the opposite, actually, but that's okay. We'll use it as an excuse. So
They're human.
accessory module addressing. So we've got our EM M1 and our EM P1 modules. That's your mixer valve modules and your pump extension modules. You can have up to 7 of those. And then we also have Vitotrolls, and you can have up to 2 Vitotrolls on the Plus Bus. 1 Vitotroll can control 4 heating circuits, okay? So again, the Vitotroll is good for room temperature feedback, as well as allowing the end user to make adjustments and programming changes without having to actually go to the boiler itself. So if you want to use them for room temperature feedback or space temperature feedback, you're going to want to position them in strategic heating circuits. But again, so it can only provide space temperature feedback for 1 circuit, but it can allow for control and programming of up to 4 circuits. And those reside on the Plus Bus as well. So taking a look at addressing them. So for your EM M1, which is your mixer modules, and your EM P1, which is your pump extension modules, those are going to be addressed via a rotary dial. And your mixer valve modules always start before your pump modules. So for example, if I had a system with 3 mixer modules and one pump module, then my mixer module addresses would be 1, 2, and 3, and my pump would be set to 4. If I had just one mix circuit and one pump, my mixer would be 1 and my pump would be 2. If I had no mixers and just a pump, my pump would be 1. So again, always start with your mixers and then the pump is last in line. We also have the ViGuide gateway data interface. So this is good for tying into BAS systems. And this supports Modbus RTU and Modbus TCP, as well as BACnet IP and BACnet MSTP. So there are 2 CAN bus networks for the boiler. So to back it up and add a little bit of clarification, there's 2 CAN bus networks and a plus bus network. Plus bus network is kind of a Viessmann protocol. It's to expand the system with our Viessmann accessories. Those are going to be your Vitotrolls and your mixer and pump modules. The CAN bus, again, there's 2 networks. One is for internal communication amongst different devices within the boiler. So from board to board to gas valve to pump to fan, those are going to all communicate on an internal CAN bus network. And then there's one external CAN bus, and that's to communicate amongst boilers in a cascade as well as to your ViGuide gateway. So internal CAN buses are factory set and there's no adjusting them. External CAN buses are set at commissioning. They're written by the ViGuide software and they're based on what the device ID of the boilers is. External CAN buses will use address 70 through 85 and a gateway is always address 90. We're going to take a look at some coding options. Now, this is not a complete list of all the coding or even close to it. This is just the ones that we figured either were most likely people would want to use, or maybe they might have some questions about. So starting out with a general coding address 528.0. This is your flow temperature set point for external demand. Pretty self-explanatory. If you program the 96 plug for external demand, and that contact closes, what do you want your flow temperature to be? Continuing with general coding, we've got gas volume correction factor and calorific value. So this is, again, this could have been done through the app during commissioning, or it is done here as well through the coding. Sorry, not during the app during commissioning, via the settings menu. Under settings, it can be done by the homeowner or the end user, sorry, if it's a commercial building, the end user, or it can be done under the coding options as well. Continuing with general coding, we've got outside temperature limit for canceling a reduced set room temperature. So this is going to fall under coding addresses we thought people might need help understanding. This is defaulted at 5. It also has a companion coding address of 1139.1 outside temperature limit for raising the reduced set point to standard room temperature. All right, so how does this work? If we look at this graph off to the right here, basically what we're saying is 1139, this is your temperature to cancel reduced temperature. So you're saying, okay, important when you're reading this graph to note that it's going from warmer to colder, warmer being on the left, colder being on the right. So we're saying if you are in reduced temperature set point, hang on, sorry, we're in actual boiler set point, normal set point, reduced set point. Yes, okay, reduced temperature set point is the blue line. So if you're going along your reduced temperature set point and you get to the threshold for 1139.0, which for this particular one is set to -5, it's now going to start trimming that reduced set point back towards the normal set point, and it's going to do it on a slope or a level of aggressiveness based on where 1139.1 is. Okay, so if I set 1139.0 for 5, -5, and 1139.1 for -6, this would basically just look like a straight line right up to the normal set point. In this example, they've got it set to -5 and -14. So you can see at -5, it starts trimming it back towards normal boiler set point until it hits -14, in which it then just rides normal boiler set point from there. 521.0 and 522.3 are just an alternate way to set your maintenance reminders. 596.0, this is your maximum heating output. So you can trim off the maximum output of the boiler. So 596.0 is for heating. 597.0 is your maximum output for domestic hot water production. So if you wanted those to be separate, you would set them differently at each address. 1100.1 is the maximum speed of the primary circuit pump. So if you were using a modulating pump, you can set what you want the maximum speed to be. And for example, there's also an option for minimum. For example, if I went to this 1240.0 and I selected number 2, which is the pump is going to modulate in line with the modulation level of the boiler burner. However, boiler specific min and max pump speeds are still observed. So if you set this to 75% as the max and the boiler is at 50% modulation, well, the pump will be at 50%. If it's at 70% modulation, the pump will be at 70. As soon as it hits 75 and above, your pump ain't going to go any higher than 75 because that's where you maxed it out at. We also have the option of a minimum heating output for the boiler. Now, this goes from adjustment from 5 to 100%, but it does take into consideration your minimal turn or your turn down ratios of your boiler. Okay, so if you have a 10-to-1 turn down ratio, the lowest you're going to be able to turn that down is to 10%. 1606.0 is your minimum burner pause time. So this one again falls back under coding addresses that may not be super black and white out of the box. So your default is a factory setting integral method C parameter 1606.4. You could set it for a fixed setting for minimum burn on off time. You go down to 1606.4 and proportional, integral, and derivative algorithms could be a presentation in itself. I'm not going to get too deep into exactly how this math all works and what it breaks out to. What I will tell you is if you feel that the boiler is cycling too rapidly, make this number bigger. If you increase this from 50 to say 100, then it will slow down the cycle rate. If you feel that the boiler isn't cycling fast enough, a smaller number will get it excited and it will cycle more often. So bigger number decreases the cycles, smaller number increases the cycles. Boiler coding address 1706. So this is going to program what some of the MZIO functions do. And you've got options 0 through 10. 0 would be not selected. Number 1 would be individual plug 66, and 0 to 10 outputs have no function. Sorry, 0 cannot be selected. 1 is no function. 2 is not an option. Let's say you wanted to have the 66 plug be an additional call for heat, yet the 0 to 10 is going to be a temperature demand input. You would set it to 9. If you wanted it's still 66 to be an additional call for heat, but instead of the 0 to 10 to be temperature, you wanted it to be modulation, you would select number 10. When you're reading through this, just understand that temperature demand is a set point, so you're going to give it a set point, and modulation is a percentage. That's kind of the key to understanding and picking the correct option you want here. Your 0 to 10 is located here, and your 66 is located here. As to why these were linked together in the coding, I don't know. I'm sure there is an explanation why they're kind of tied together, but just to clarify, that's what's going on here. Is you've got options for 66 and you've got options for the 0 to 10 in, and you just got to read what it says and pick the correct one, because 9 and 10 perform the same function for 66, but change the function on 0 to 10, as where 6 and 7 perform the same function for 66, but change it on 0 to 10 again as well. So just read it carefully and make sure you pick the correct one. There is additional call for heat on plug 66, so you want to see parameter 2445 as to whether that's going to be a call for additional boilers as supplemental heat or a call to this boiler as supplemental heat. 497.0 is your operating mode for your DHW recirculation pump. So you have 0 is following a time schedule, and 4 is selected cycles as based on parameter 497.3. So if you selected 4, then you got to go down to 497.3 and pick your number of 5-minute cycles per hour. So if I wanted this thing to come on for 5 minutes every half an hour, I would select 1, which equals 2 cycles per hour of 5 minutes each. .0, this is your circulation pump run on time. So basically what this is saying is you have a call for domestic hot water, your boiler has gone in domestic hot water production mode, and your tank loading pump is on. Now your tank sensor reads that you finally hit your set point and the boiler shuts off. How much longer do you want that pump to run on to dissipate heat into the tank before it switches back into possible heating mode? It's a good opportunity to get some extra heat out of the system and into the tank, not let it go to waste. It's also can be helpful to reduce the boiler water temperature before switching back into heating and shocking any of your heating zones that don't want to see a really high temperature. 1085.0, this is cylinder heating start point. Okay, so your end point is fixed. Okay, this is essentially your hysteresis. If I set my boiler to 120 degree Fahrenheit as my set point, the end point, irrespective, is always going to overshoot by 5 degrees. So it's going to come on, it's going to produce domestic hot water. Again, my set point's 120. It's going to wait till 125 and shut off. The question that is being asked here is how much below 120 do you want to let it go before it engages domestic hot water production? And the default is 25, which works out to 5 degrees Fahrenheit. So if you left it at the default and you had a set temperature of 120, at 115, the tank is going to say, I need heat. The boiler is going to come on, give it the tank loading pump. It's going to produce heat into your domestic tank, and then it's going to wait till 125 to shut off. So it's not cycling as frequently. 1087.0 is your max duration of DHW heating. This is a DHW timeout function. So in the event that for whatever reason your tank never satisfied, so it's the boiler's running along, it's got a call for space heating, and then all of a sudden there's a call for domestic hot water, so it goes into domestic hot water production, and let's just say there's an extreme load on your tank, and 60 minutes goes by and domestic hot water is still not satisfied. Well, if that's what you set this for, after 60 minutes, it'll say, okay, I'm giving up on domestic hot water for a bit. I'm going back to heating. And then 1087.1 is how long does it give up on domestic hot water before it then goes back and tries again. If you don't want this function enabled, set 1087.0 to 0. and there will be no timeout. It will just always continue to produce domestic hot water until that tank is satisfied. 424.3 is your set flow temperature increase when switching from reduced to normal mode. So said differently, if you're coming out of setback, so let's say your design condition is that you need to have 50°C water to keep this building at temperature during the day, and you let it go back to 30 at night. Well, if 50 is what's needed to be maintained, that's your maintenance temperature, you're going to want to bump that up a bit as a morning warm up, let's say, so you can get up to temp and then maintain it from there. So address 424.3 is how much over normal temperature set point do I want to go? And 424.4 is for how long. So if I said I wanted it to overshoot by 5 degrees, I would set this to 5 degrees higher. And then for 60 minutes, then I would set this address to 60 minutes. Gives it a chance to give that system a chance to push that building up to set point as it's coming out of its reduced temperature mode. Then it drops back down to its maintenance temperature once the building's up to temp. 933.3 is DHW heating priority. So this is only available for heating circuits. It's not available for heating zones. Keep that in mind. So your heating circuit can be without DHW heating priority or with DHW heating priority. However, this is only adjusted in conjunction with a low, like basically you have to have global domestic hot water in order to switch over the priority or not. 1192.0 is minimum flow temperature for heating circuit. 1192.1 is maximum heating temperature. Now these are for heating circuits 1. Heating circuit 1 here. There'll be a similar coding option for circuit 1, 2, 3, and 4. There's an option for all of them. I just wasn't going to go through each one. It's defaulted to 20 and 74. So essentially this is regardless of what your heating curve is calling from, this is your minimum and this is your maximum. So you can still set up a heating curve and follow along in between based on outside temperature. But in this particular example, you're saying, I don't really care how cold it is or what the heating curve says. Once you get to 74 degrees Celsius, you're not going any warmer than that. And once the set point gets to 40, you're not going any cooler than that. Taking a look at how we're going to read our fault status service warning and information codes. So as I mentioned, it's a different way of alarm handling versus the older generation of Viessmann controls, the Vitotronic controls. So how do you address an active fault message? So if there's an active fault message, there will be a triangle displayed along the bottom soft keys, as well as the light guide will be flashing rapidly. So the first thing you're going to do is press that triangle. You're going to select faults. And you're going to press this X with a counterclockwise circular arrow around it. This is essentially the reset fault option. Once you do that, this burner fault screen will populate. This box will be unchecked. You're going to check the unlock box, hit the check mark, and the system will check to see if the fault is corrected. If it's not resolved, the fault will then populate back up. It'll go to this screen again, and there will be a fault because you have not corrected the issue. If it is corrected, it'll recycle and populate no fault in the box, and you're good to go. The 10 most recent faults, including those remedied and not, as well as service and maintenance messages, are saved and can be viewed by, you're going to navigate to message history. So this is done in the service menu. You do have to enter the service menu, navigate to message history, going to select your desired code. Do you want faults or status? Use the up and down arrow to pick your message. You will notice that they're all time and date stamped, as well as it tells you the participant number. the most 10 recent faults, including those remedied, can also be cleared. So this previous steps was how to view them. Now we're going to talk about how you clear them. Same steps. You go to message history, pick the one that you want. And in the bottom right corner, you will see a trash can. You click that and you indicate that you want to delete that message list. Now you can clear faults and statuses independently. You don't have to clear them all, but you do have to clear the entire list. You can't just select one or two out of the list and clear it. But again, you can clear just the fault list and keep the status list, or just the status list and keep the fault list. So the messages are broken down into 5 categories. That's service messages, status messages, warning messages, and information and faults. Your service messages begin with a P, status an S, warning an A, information an I, and faults an F. And then that's your prefix. And then after each one of those, you'll have a dot and then the specific number of the message. So here's just an example of some faults. So again, the prefix for fault code is always F and then the 7. So that's indicating it's a fault 7. This is what you're going to see in the manual, this sheet right here. It's going to tell you what the characteristics are. So what's going to happen in the event of a fault F7? What will happen is there will be no DHW heating available. You will get the cause. Well, the cause is a lead break at storage tank temperature sensor. Well, this explains now why no DHW heating is available. And then you also get a little bit of troubleshooting information. So it's going to tell you, check the settings. Is it correct? Maybe somebody accidentally set it for temperature sensor when really it's an aquastat, where that could lead to that fault. It's going to, tell you to check this sensor at plug 5. If you go into the manual, it will give you a resistor curve for that sensor. And then it will tell you to measure the voltage at the center input on the electronics. So without the sensor, or with the sensor disconnected, you should be reading a value of 33.3 volts. This obviously, as mentioned, this is clearly not a complete list of faults. This is just an example of how to read the faults and how to go into the service manual and read the fault code tables. As I mentioned, you're going to have a subscriber number. So the message descriptions include a participant number of the component on which the fault has occurred. So again, we have CAN buses and we have plus bus. So for the following is your plus bus participants. So your EM M1 and EM P1 extension modules, those are going to be 1 through 15. Your EM A1 are 17 through 31. Your Vito trolls are 48 through 63. So you can see here, there'll be a nice little table in your service manual. It'll say, okay, if your Vito troll address is set to 2, then that's 49. So if you come into your faults and you have a fault on participant plus bus number 49, well, then you can see this and know that, okay, I got to find out which control is address number 2 and figure out what's going on there. As for the CAN bus, we've got the same thing going on. Your heat management unit is 1. Your BCU, your burner controller, is 50 if it's a single burner boiler, and it could be 50 and 51 if it's a two burner unit. So 50 is for the first burner, 51 for the second burner. Your TCU is 58, your HMI is 59, etc. Your cascade is going to be 70 through 85. And your gateway is 90. So if you notice, we've got the single asterisk and the double asterisk. So the single asterisk, those are on your internal CAN bus, and your cascade as well as your gateway reside on your external CAN bus. This is just an example. I snipped this right out of the manual just to show you that this is labeled in the service manual. You don't have to remember it from this presentation. You go in and it'll tell you what plus bus or CAN bus subscriber is associated with each component. Lastly, we'll take a look at some checks to verify correct operation. So obviously we want to make sure that our gas pressure is correct, and that includes both static gas pressure as well as dynamic gas pressure. So starting with the static gas pressure, you're going to shut the gas valve off. You're going to find the test port. It's a little nipple on the gas valve. Inside that, there's a little pin, and you're going to back that pin off. You don't need to take the pin all the way out. You just need to loosen it and slide your manometer tube over top of the nipple. You're going to then open the gas valve and measure. So this is static. This is done without the boiler running. And you want to make sure that you are within the appropriate ranges if you're using liquid propane or natural gas. Next, we're going to measure our dynamic pressure. So to do this, we want to use the actuator test to start the burner. As mentioned, all dynamic measurements must be made under high fire. I personally would go one step further and state that all dynamic measurements should be made under high fire with all appliances sharing the same regulator under high fire. Okay, so if there's more than one piece of gas-fired equipment sharing that same regulator, really all of it should be in high fire to do a proper dynamic gas pressure test and make sure that that doesn't dip down when there's a lot of demand on the regulator. You're going to measure and record your running pressure. Again, you're looking for 4 to 14 on natural gas and 10 to 14 on liquid propane. And then once you've got that, you're good. You're going to switch off the heating system and close the gas valve, retighten that pin, take your manometer off and retighten that pin, check for any leaks, and you have completed your gas pressure checks at that point. Checking the combustion quality. So for burners with 2 burners, each burner must be measured at the respective inspection port. So basically, if you look at the way these boilers are laid out, is there's 2 burners, if it's 2 burner unit, and then those meet in a common flue gas box, I'm drawing a blank on the word here, collector box, before they enter the flue. So if you were to take your combustion measurements in the flue, you're not going to get an accurate reading of any one boiler because the other burner, or that any one burner, because the other burner is either going to be running or it's not going to be running, but its fan will be on ever so slightly, and that will give you an incorrect reading. So there is test ports provided on the front of the boilers, right in under the heat exchangers here. It's right in the heat exchanger clean out inspection port. So you can take this larger port out if you wanted to look inside the heat exchanger and clean it out, or right where this little red dot is here is a plug that can be removed, and you can insert your combustion analyzer and check each burner individually before it meets the common collector box. So keeping in mind that emissions test, you can enter the emission test mode, but that only runs the burner in high fire. I recommend using the actuator test because that allows you to run the burner in both high and low fire. The combustion controller does carry out an automatic calibration on startup, so we recommend that you allow for testing the emissions, because if you do it too soon, could be in calibration mode. General rule of thumb, when you're checking your combustion quality anyways, you want your heat exchanger to be hot. So I would go even a little bit longer than the 50 seconds recommended if you're just firing that machine up. Your permissible CO2 or O2 content are as follows. So really, we're mostly going to be looking for 2.1 to 8.4% O2 or 6.9 to 11% CO2. And it's the exact same, or sorry, it does change slightly if you're using liquid propane. The oxygen value does not change, but the CO2 value does. It goes from 6.9 to 11 to 8.3 to 12.4%. This is just showing you how you would enter that. So combustion test is available through the service menu. You go to test mode and you can enter emissions test mode. You also have the option for activate a high limit test. Again, I'm recommending, so that's method 1, using emission test mode. I'm recommending using actuator test because you really should be checking your combustion in both low and high fire. And when you use actuator test, you will get the ability to switch from low to high fire on the fly. Just an example of what that looks like on the HMI. If you're in actuator test, you're going to want to start your pump. Make sure you got a decent flow. If you're controlling the pump, it could be third-party control, then you got to figure that out. And then you can start it off in maximum heat and then dial it back to minimum, and you can test both in one shot. High limit safety test is available through the HMI. So you're going to navigate again to the service menu, go to test mode, select activate high limit test, and you're going to see a screen like this. It's going to tell you your actual temperature. This is a bad example. This would typically say like 99 degrees Celsius or whatever the cutoff is for that high limit. Does vary slightly from one boiler model to another, but it's going to tell you what its trip limit is and its actual temperature, and you're just going to see that thing ramp up until it trips. And what this is doing is it's using its own information to ramp the burner up and crimp the pump back in a way that is not super stressful for the heat exchanger. So it's taking it to the limit and over the limit, so it trips the limit, and you can test it, but in a way that's not going to shock the heat exchanger and put any unnecessary stress on the heat exchanger. That's the end of what I had for you. So thank you very much. As I mentioned, Scott did his installation presentation twice already now. So if you haven't seen that, the videos will come out shortly, as well as Mark did some applications, and there's some really good content in both those presentations. So if you haven't seen them, check them out.
We have questions.
We got questions or no questions?
We have lots of questions.
Uh-oh. Okay.
What
are the
saved them all
questions?
for you. We saved them all for you here. So let's go through.
I see that. That was so kind of you.
I know. That's just how we.
We figured
Seeing
we'd
how
throw
your
you under
voice
the
is so
bus.
clear today. Yeah.
Oh yeah.
We just wanted to throw you right under the bus.
I felt like the longest hour and 20 minutes my throat has ever experienced. So,
So
what are the questions?
You labored through, man. You did really well.
The first one was about the buzzer. I'm not sure what about your
Is the buzzer an audible alarm?
Yeah, whether
No.
you use the term buzzer, it's an output, right? And
I think you might. Yeah.
When you talk about the buzzer, I think you were talking about when you mute the alarm.
I think you might be referring to. There's a buzzer on off button, and I think that I'm not going to lie. I question that myself. I think it's referring to when you push buttons. Is there like a beep?
Well, there is a
Right.
bing, yeah, but you can
Audible.
turn that bing on and off, yeah.
That's what when you go into that display settings and it's worded buzzer on off, but that's what it is do you want to hear the audible ding when you push the buttons?
Yeah.
That's what that setting's relative to.
The other thing, and I'm not sure what the reference was, but the other thing is that when you're in the fault and it has that icon on the screen that there's an alarm, or that and you're in the fault, there's a little speaker with a line through it.
Yep.
That the alert doesn't clear the alarm, but it turns off the alarm output, which is the 66.
Okay.
So it's kind of like a silent button, right? So if you had a bell or a horn hooked up to it, it would silence that, but the alarm doesn't go away until you fix it or you reset it, right? And that could be also something as well. And I think that leads to his question a little bit farther down the line, that where does it go, right?
Yeah, it's the 66 plug. This is what I was trying to explain, and this, I don't know, I find this, it's clear once you understand it. It's not even that hard when you look at it. It's hard to talk through it because you're programming two different.
Yeah.
You're programming an input and an output together, but separately. So there's two of these, this output and this input, the programming is linked together. So you have to pick a selection that has both of them doing what you want them to do. But to answer that question,
you got to turn your left blinker on when you turn the steering wheel left.
Yeah.
It's two things to do one thing, right?
Well, it's even different than that, though. But yeah. So I think to answer that question, I believe he's looking for plug 66. That's where it's going to output to the alarm.
1706. Yeah.
Yeah. What do we got next? We got, can you
go
go
over
the 139?
I think it's 1139, which was that address where the set point changes.
Oh yeah, there it is.
So let me try to grab that, because I beat my head against the wall when I first read this on the old controllers. So The idea was that you see the dotted red line and the dotted blue line. The dotted red line in a heating circuit is your daytime schedule, and the dotted red line is your nighttime schedule or off time schedule, your setback schedule. So the way the control uses that is it pushes what we call the room set point, which unless you have a ViTrol in the space is a virtual number from a position here, let's say 68 Fahrenheit down to like 40, 38 degree Fahrenheit, something like that. But the idea of this address is 1139.0. If the outdoor temperature drops to, in the default being -5, it starts to push it back towards the daytime calculated set point again. And by the time it gets to -14 by the default, it's running at the daytime schedule. And the point of this is that if you had an installation where your design day is X, and you decide there's days that get colder than that, but they're not really, you could say like Toronto area where we are, ASHRAE says the design day is -20. But there's days we have that are -25, 28, 30 in the wintertime. So the idea would be that you'd be able to take away the setback when it got really cold outside, so that the boiler didn't get behind. It didn't take too long to recatch the set point when it comes out of setback again. So these two numbers, the default numbers, are a little bit high for most places, except for maybe where Scott is on the West Coast, where it's rainy and warm. So at -5 in this example, at -5, it starts pushing the setback back towards the daytime calculated set point, which is the red line. So there's no setback at that point. So if 2 o'clock in the morning, it's -14, we're running at the daytime heating curve, not the nighttime heating curve. I hope that explains it.
So I guess, yeah, it does to me anyway. Next question I see is what address do you set on a leg boiler for a minimum set point? Basically saying the scenario where the lead boiler fails, loses power, and you want the lag boilers to continue to running for an indefinite amount of time. So I just want to clarify the first part of that question is, if the lead boiler fails but doesn't fry key components, let's just say it goes out on a flame sensor fault, then it will just it'll just run the normal outdoor reset and everything like that. It just shuts itself off and passes all the demand down to the lag boilers. However, if the lead boiler actually has a power failure, which is what you're describing there, or it fries the board that is responsible for that communication, basically what it is it's parameter 24551, and it's what will happen to the lag boiler if it loses communication with the cascade master. And then the default is nothing, and then you can turn that on, and then you can set a value in temperature. So let's say you wanted it to all the lag boilers to go to 60 degrees Celsius in the event they lose communication with the lead. You would enable that, turn it to on 24451, and then put in the temperature you want them to go to. At the current time, that is not available through the HMI. You have to go through Vitoguide to get to that particular address setting. So if you do have a situation where you want that, for the time being, you got to contact tech support and make sure the boiler is connected to the Wi-Fi or to the internet, and then tech support can go in and set that up how you want them to set it up. I apologize for that inconvenience for the time being. We're going to get that pulled down into the commissioning assistant on the app, but for the meantime, that's not there again. So the tech support has the ability to get into the background and add that setting and how you want it. You just have to make sure the boiler is connected to the internet so they can get on and make that adjustment.
And I think we're hoping to have that done before you actually get a physical boiler in your hand, so it may not be a mute point.
Yeah, it shouldn't be an issue. The goal is the goal is that when you go through the commissioning assistant, and remember how I pointed out that the lag boiler has a lot less questions asked than the lead boiler, well, that will be one of the questions asked during the lag boiler. In the event of a comm loss, what flow temperature set point do you want this boiler to maintain?
What manual defines?
Service manual. That's the service manual.
Yeah, anything related to coding, addresses, fault codes, anything like that are always in our service manuals.
Yeah.
how do the two burner systems work on the 1500 and the 2 million? Do they modulate together? Then the second 66%, then the second burner comes on, and then they both modulate up and down accordingly, or do they operate as each? They operate together unless it is below the minimum firing, or sorry, unless it's below the minimum firing rate of both burners added together. So as soon as the requirement or the capacity exceeds the minimum firing of both burners together, then it will go to two burners. It's always the start that tops, or the start or the bottom that starts, Mark, I forget.
I think it's the top that starts. It's always the smaller burner that starts first, which is the top.
Right. So if you had, let's say you had the the 2 million. So 2 million is a 20 to 1 turnaround. Each burner is a 10 to 1. So you've got two 1 million BTU burners. So the top burner will start until so it'll start and run up to 200,000 BTUs of capacity. Once it hits 200,000 BTUs of capacity, now that can be split between both burners at 10 to 1, which would be 100,000 each. Then the lead burner, the top burner, would ramp down from 200 to 100, and the leg burner would come on and match it, and they would ramp up together from there. Now, if somebody else wants to try to step in and explain that differently,
I think you did that pretty good. So, so there is a like a minimum firing rate of each burner. So on a 1.5, it's a little less than the 2 million, right? So you add those two together. That's why there's a 15 to 1 turn down on that. But one of the things to understand though is that even though one burner's running, let's say the top burner starts because it's always first, the fan on the bottom burner will run and it will match the fan's capacity. So if it's a 1 million and a 2 million BTU burner, it's obviously going to have a different fan speed because the 2 million burner has a bigger fan. But it's going to match the air volume velocity for both burners. And that's so we don't get flue gas coming back into the first burner. And once it gets to that threshold of 2 minimum burners, the second burner starts. And because the fan is already running, there's no pre-purge time on it. It just basically starts.
right? And that'll be true. I was thinking about that literally like live in the presentation. I was thinking about that when I said that you have to take your combustion reading below, like in the test port for each individual burner. And then for a second, I was thinking, well, wait a minute, I can go into actuator test and fire each burner off individually. So why can't I take it in the flue? But then as Mark just said, regardless if I'm firing off burners individually, the fan of the other burner has to run at the same fan rate. So that's why you must take your combustion analysis at each burner respectively.
Okay, and the next question kind of is connected to that same area of the boiler. When you talk about the clean out cover, life expectancy, you got to remember that where that clean out cover is, you'll never have a flue gas temperature higher than 110 Celsius. So it's not very hot. And it's not just press fit in there. It is press fit in there, but there's 3 clips like cotter pins that hold it in place. So it's not like it's going to pop out if there was a combustion bump. But the maximum flue gas temperature at that point, because the heat exchanger is going to take away all the energy from it, the maximum flue gas temperature is only going to be 110 Celsius.
And pressure there is probably what, 2.4 inches or something water column. So not a lot of pressure on that.
Yes. And yes, there is a combustion test port in the front of each of the cleanouts on each of the portions. Yeah. So if you're familiar with our Vitoguides, they have the little gray plugs. They're like that. You pull the gray plug out, you put your analyzer in there and you measure it. It's just that we have one for each burner because once it gets beyond the bottom of each heat exchanger, it's a common flue.
I mean, if I had an 8 boiler cascade, it might not be the worst idea to order one clean out as a spare part just in case somebody does something to one. But yeah, I don't see any issues with it. Like Mark said, it's in cool temperatures and it's designed to handle the product's combustion. And yes, the high limit safety test is nice because the engineers may still want to, or the inspectors may still want to see it, regardless of the fact that it's a redundant sensor that's self-checking against itself all the time.
Yeah, in the reality of it, there's no reason to actually have to do a physical high limit test because they're not mechanical limits anymore. When you had a mechanical limit, the only way to test it would to drive the boiler to the point where that limit opened. But in our redundant temperature sensor system, where there's two sensors always measuring the same place, they check each other, and if they drift a value away from each other, then that says one or the other sensor is not correct, and it will generate a fault. It might be one of three faults. It might be 3A, and use the boiler water temperature as an example. 3A is a fault, or 3B is a fault, or the drift. So you could have any one of three faults for that. And it's automatically self-checking. So it's checking itself continuously through the operation. So I don't have to worry that, well, what if the mechanical limit is stuck? But you will still get inspectors, your government inspectors, your insurance inspectors, your local gas guys who are going to say, I want to witness the high limit test. And you could do that through the emission switch. You could turn the emission test on and drive it. But remember, the emission test drives the burner to high fire. And when it hits that limit, it's going to go boom and it's off, which is the way everybody does a high limit test. When we do it the way we're doing it now through the high limit function, it trips it softly. So we put the minimal amount of stress on the boiler. The mechanical limit test, you have to drive the boiler to a temperature you don't want it to be at, right? And in stress on the machine you don't want to have there. So we figured out a way to do it with a minimal amount of stress.
Yeah, no, I know I've had a few classes with boiler inspectors and stuff like that, and this function is just cut out for them. It just makes it easy for us not to have to bypass anything. It's just push the button and they can sit there and watch the boiler trip on that fixed high limit. So it is a real nice function, even though you can debate the requirements for sure.
Yeah, and it's like anything that's fairly new technology. The redundant sensor thing is pretty new to be approved as a safety circuit. And maybe at some point the inspectors will understand that they don't have to do that anymore. But at this point, everybody in that market, or everybody in that industry is used to the mechanical high limits because there's so many of them still out there.
And just for further information is, as you advance through the commissioning assistant on the app, as you get to the end of each leg boiler, it will actually give you the option to perform a high limit test at that time. So it can be done then as well. I like doing it on the display itself because it gives you I like the feedback you get better on the display than through the app, but it can go either way.
I think we got them all.
Yeah. Perfect.
Save the best for last, Curtis. You had the most questions. That was good.
Well, yeah, you did.
Nice.
No, they were good questions though, because they were all, I like those questions because those are all in the areas that as I was going through it, I'm like, I don't think that's as clear as it could be, but yeah, you gotta, that 1706, I don't know, that one gets me every time trying to talk my way through how to program that.
It's a tongue twister.
It is, yeah. So, all right.
Well, excellent.
Excellent.
If we don't have any more questions, I don't think there's anything else in there.
Looks good.
No, it's good.
Mark's gonna kick you all out then.
Yeah.
Well, don't make me the bad guy.
We'll do it on 3 then.
It's like at the party or at the hotel or at the wedding where they turn all the lights on and come out with the vacuum cleaner. This is the virtual version of that. So.
Or your mother came down the stairs when you were a teenager and told it was time for everybody to go home.
Yeah, that too. All right.
All right. Thanks, guys.
You guys have a great day. Bye-bye.